Hi, everybody. Welcome back to another episode here of Atomic Corp plays with open source security. I think we're actually gonna call this open source security. That might
I
be a
like
good,
it. I
yeah,
like it.
yeah. We're gonna call this open source security. So first off, there's background to that. My name is Scott. I am the project manager well, I'm the CTO here at Atomic Corp, but I'm also very much involved in a lot of open source security projects. One of them is called OSSec, which, funny enough, stands for open source security. And I didn't actually know that until I think I met Dan Sid, who created that project, in person like a couple years ago. And I'd been working on this since like 2006. Anyway, we're going to call this program open source security. The next broadcast on Friday of next week, we'll be putting it onto YouTube and Twitch. Right now, we're just doing it in Zoom, but all of these videos will be saved and shared. Definitely to our YouTube channel and to some other stuff like that. But as it turns out, we'd been working with met up with some people from MITRE. They had been this just happened to be a coincidence. They were looking at or looking into malware based on a Linux function called eBPF, which I'm going to explain here in a sec. We really aren't focused on specifically on malware here. It's one of the things we do. We're on open source security, so we're working with tools like ClamAV and mod security, and our first program was actually on reverse engineering malware with a tool called Ghidra. Um, and we're going to revisit it. So first off, let's talk about what this is in the malware landscape. And I just realized I'm not even broadcasting, am I? So in the realm of malware with Linux, it can certainly land in a lot of different places. There's unprivileged malware like web shells, which we did early on. There is more privileged malware that is operating as what we call a rootkit, where it's either affecting a component of the platform, like a service or a binary, or even more deeply into the Linux kernel itself. And what we're talking about now is a type of malware that is as deep as it could possibly go, and it's going to be exercising a particular function in the Linux kernel called eBPF. So the BPF part stands for the Berkeley packet filter. I know that doesn't really mean much. It sounds like it's a firewall or something like that. But basically, what eBPF lets you do in Linux is uh, extend the network capability of Linux without you having to modify the kernel, right? And so what we would call that in sort of kernel to the rest of the operating system, we call that user land. And I had a question come over that said, "What is a kernel?" So a kernel is what lives between the hardware on a piece of equipment and the applications that you're using. So in the kernel is its job is to do things like that's your network drivers, to be able to understand things like how to be able to uh, read disks and file systems. It's what's managing the memory and processes and all that. So typically, as a user, you're running applications which run under the kernel, and the kernel is what's talking to the hardware in the system and controlling the video and the network and all that. So what's unique about this eBPF piece is that we can create some kind of capability in the Linux kernel that didn't exist anymore without you having to modify or even reboot the system into that, right? And it's got a lot of use cases. And this isn't a bad piece of technology at all. It's a very powerful thing. It's very useful in the realm of containerizing things and really building cool applications. But in the world of abuse, and you can see here they're talking about using this for sandboxing. You could use it for sandboxing, but it is not itself a security function, right? It eBPF is very much just a capability, right? You could use it to sandbox things, and what's powerful about this is that because you have in essence a user land application that is able to see what is going on, what the network is doing and what the kernel is telling the services and the applications user land, you can actually use this to create covert channels, right? So here would be an example. If I have BPF malware on a system, and I am communicating to it through the outside, and then I run a sniffer on my own on that same system, I would not see I could configure it so I couldn't see the network traffic from it, right? In essence, I could use that to hide network, um, you know, some kind of, like I said, covert channel, right? You could also use it to do some other interesting things, where you can manipulate what a user land application sees. So let's say I am on the compromised system and I do a DNS lookup on a domain like google.com or something like that. I can intercept that through eBPF and manipulate the response. I could do the same thing with SSL, right? Like I definitely could do some crazy stuff to manipulate SSL certificates and things like that. So it's a powerful thing. Now, when we were talking to the MITRE folks about the BPF malware, I personally have never seen it in the wild. I mean, I know it exists, right? It's clear to me that it exists. We're going to look at some that's been captured, but I'm kind of going into this cold too, right? Like I know I've done a little bit of light research on the malware out there. I've found some stuff on the uh, I found some source code, right? And I don't know if that's the source code of the thing we're going to be looking at right now or not. But I've looked at it. I was like, wow, this is shockingly simple, right? It's written in C. It's pretty simple, but very powerful at the same time. Just a little, if you're kind of coming in new to rootkits in Linux or Windows or whatnot, this is the more hardcore stuff that it can do. A typical thing that a rootkit can do, because I saw a random comment on the one of the security channels about other things it can do. If you have a rootkit on the system, it could be in the kernel, it could be in a library, it could be in an application. Typically, these rootkits are pretty sophisticated and they'll be in a mix. So leaving the eBPF stuff aside, it can hide, right? You won't see it with LS if you list in the file system. You won't see in the process list. It can hide from your ability to detect it. So just in general, this is from one of my peers in the Rocky Linux community. If the system is compromised with a rootkit, you can't trust anything from it at all anyway, right? So you shouldn't be trying to do forensics on the system from the system. You're going to have to get a clean snapshot. What's interesting to me on this BPF stuff, though, is that now we're talking about effectively extending that, extending the ability to do kernel level rootkit stuff without having to actually modify the kernel, right? We can just tell it through eBPF rather to talk to this user land process, and now we're able to manipulate the network, right? Which is interesting on itself, because if I'm using things like digitally signing kernel modules and the like to prevent Linux rootkits from loading into the Linux kernel, that's not going to help me against this vector, right? Like I can still run that. That BPF malware, and there are other ways that I don't have to use to touch the kernel to be able to hide that. So anyway, let's actually take a look at some of this, because I'm going in cold on this. I do want to thank Tim, who is the one who's collected the malware here. Tim Brown is I've met him in the MITRE Slack. He's doing work on this as well, and I asked for some real malware to play around with. Now, I don't know anything about the backstory on this malware. I don't know how it was found. I don't know. I mean, it came from Malware Bazaar, but I don't know the delivery mechanism or anything like that. So, as far as how it got into the environment, I don't really know. We're just going to take it apart and take a look through it. And if you want to take a look at Tim's GitHub, he's got a great collection of malware in here that we might come back in and look at in some future some future videos that we're going to do here. So there's a lot of, I haven't looked at it, honestly, any of them. I'm just like, great, awesome. Look at all this. Look at this great big list of stuff. We can play around with some different countermeasures and detection methodologies for these guys and pick them up. So without further ado, I'm going to go into the sandbox over here and grab some of this stuff, and then we're going to run it through Ghidra. And I apologize if my screen keeps flipping here. I'm trying to catch up on some of the other feeds where people are may or may not be asking me questions. I'm in multiple Slacks, Mattermost, and they're all in different windows here. For the future, though, I think probably what we'll do for this is we're gonna just consolidate questions into one Slack or maybe one Mattermost. Not Discord, probably. I just don't feel like I need to add another app on my system here to try to watch all this stuff, because I'm looking on one monitor to see comments and questions, and then over here the one that I'm displaying is kind of a chore. Okay, so let's grab this off the system, and then I'm going to first see if any of these things are SIG'd. Again, I don't know any backstory on any of these at all. Let's just call it BPF. There's a BPF tool, I think it was called. BPF door. BPF door. Now my sandbox system here is it can only talk to specific destinations, and then in a window I'm not showing you, I'm shutting the network down for any outbound traffic on this guy. All right, so let's start with the basics. We have about a 144K binary. I bet it's probably static. Nope, I did not grab it raw. I grabbed the I grabbed the HTML there. I was going to say that looked way too big. Yeah, usually C malware is going to be pretty tiny. 35K sounds about right. So let's take a look at this guy. Yeah, there we go. All right, so a couple of things to look at this right away. It's dynamically linked, which I didn't expect. I would have expected this guy to be statically linked. Moreover, it's also not stripped. That means it's going to have our symbols in there. And I'll fire this guy up in Ghidra because it's still getting used to what we can do with Ghidra. Oh wait, where did I put you, Ghidra? I don't think I put it in the path. I think I just downloaded a binary into the directory. Still learning my way around this. So I'm sure there are people who are much better with working with Ghidra than me. Please let us know. Always happy to share our time here with other folks who are interested in doing any malware research or whatnot. So let's take a look what we got here. Now this is going to look at we're pulling this out of the header and some of the interesting stuff here. So this is always a good sign. When we see the number of functions right here, 145, which is a lot for C, means this thing has probably got a lot of interesting stuff going on. Take a look at some of this. This is interesting. Okay, so because they didn't strip the symbols out of this, we actually have some of the original file names in here, which I'm sure we could just Google for, and I will bet you, for all I know, this is up on GitHub already. And reverse engineering the binary here is probably not as important. It could also be that this was put up by somebody else who did research on this already. Again, I don't know any of the backstory on where this stuff came from. That Go malware we looked at last time was pretty cool. I was super happy on that one. Okay, the other things that I always do on this, this is me running it through analysis. I always set the decompiler parameter ID. That's about it. You don't have to do this, but it will make it does make lookups a little more sane. It can be wrong though, so you may want to play around with that. I know it's probably driving some people crazy to have that many windows overlapping. Okay, I always start my next thing. I go to functions, and I want to see function names. Okay, if you were here or you saw our other video on Go, when we first did this, there were none, right? Because Go is a little different. This happens to be C malware. And we've got a nice list here. This is, and I love it. I love when somebody writes their function names to tell us pretty much what they do. Like shell, I'll bet you that opens up a shell. But let's look at main first, right? So you start with main, so that way we can kind of, there's two ways to find main. One, you can just look at this list like I did, or you can go into filter and find main. I do like seeing all the other ones in here. Actually, let's go through that first. Let's take a look at some of these function names and try to guess what they do before we actually go into and see what they do. So do global detours aux. That sounds to me like it's probably some kind of network function. Gmonitor start, probably also some kind of network function, right? That's our BPF piece. Deregister, not sure. Start, okay, start something. B, don't know what you do at all. C, read and write, yeah, probably writing files. We got one function where we didn't get a name right there. Get shell, probably some kind of magic packet sequence that tells this guy to open up a covert channel or whatnot. Let's see, we got log on, probably log on. Monitor. What to do when something terminates is my guess. Open a TTY, that's definitely going to be related to a shell. Packet loop, maybe there's some kind of packet generator in here. We got shell, trilink. All right, let's take a look at main. Now there's a couple of things you can do when you have a decompiler here, and I gotta pull my window open. And I'll get that guy open again. Again, I'm not the best. I'm not by any means super familiar with the interface here. This is looking at the raw assembler here, and there's a decompiler window, and I can't remember how to open it. Maybe under Windows. Is that you? Yeah, here we go. This guy. So let's go back to main. Yep, we're at main. All right. So this, no, that's shell. That's not what I want. I want you. Open up the window. And our video is watch Scott struggle to figure out how to use the interface. There we go. All right, here's main. And the parameters were values that it accepts. So usually, like, main, if you're not have done a lot of work with programming um, in C, and main is basically where we declare that the program is going to start. If we were looking at like PHP or some other class-based malware out there, the fact that somebody might call it main is going to be coincidental. They don't have to. They can call it whatever they want. It's a big deal with like web-based shells, and whether we're talking about ASP or I don't know. Does ASP use main? I don't know. But like certainly when we're dealing with PHP malware, you're not going to be looking for main. The good news though is you're not going to need a tool like Ghidra to look at it at all in the first place. The first session we did on malware was PHP malware. We didn't record that video, but there are obfuscation techniques that can be used over there, and we will talk about that maybe in the future. But let's go over the C side of things here. So it's going to call it a main. If you're looking at Go malware, it's going to be main.main, but either way, main is what we're looking for. And these are the elements that we've got in the beginning of the code, which is they're basically instantiating variable types. I mean, I believe these are probably command line parameters, but let's look through what these things are being set as. Right away, we've got things that are set for system level applications. So udev, mingitty, console kit, and some of these other functions here. That's interesting, audit D. These might be for enumerating capabilities in the environment or looking for something that might detect you. But these other, like mingitty is what provides a console, typically locally, right? But you can use mingitty to bind to a network service, and I'll bet you that's what they're doing. And I can kind of get that right away when I see them use a name like dev tty7 in Linux. If you've ever been on the console of a Linux system, you've got a TTY, that's what you're looking at. And you'll hit like Alt F1 or Alt F2, Alt F3. Those will give you different consoles. I'm talking fully text, not like anything X-based, or we're not going in through SSH. 7 isn't one of them, right? You can go higher, but 7 is not one of the ones that you would see on the list, right? You would just see usually 4 or maybe 6. You certainly wouldn't see an odd number like that. So as a rule, an indicator of a piece of malware can be a simple indicator of a piece of malware that you're just, you're hunting through the file system or you're hunting through binary code. If you see something like that is maybe a generic indicator of malware, right? Like something that's unusual. It's unusual enough to pop up on my radar. Okay, so seeing this is kind of neat. Like I didn't expect to see that right there. All right, let's keep going. So we've got a bunch of values, PID path. Probably these are looking for basically PID files are used to track the process ID number per running process. They would be dynamic though, mostly. Some of them are going to be predictable, like one is an important process one there. Okay, so we're going to look through. We're looking for our PIDs. That's so fine. var3, that's getting the user ID that this application is running as. My guess is they probably run this as an unprivileged user to start with, and then use that to set up ports and whatnot. But again, I don't really know the backstory on that. It would be helpful when you're looking at these things to understand how they got on the system, or at least how these were discovered. It's entirely possible that these were found on a what we call it, a dropper, covered in our first video. Tools that are basically ways of extending malware in an environment by having a piece of malware download another piece of malware, right? Just call it a dropper on that front. Okay, let's keep going through here because we are almost half an hour in already, and I really haven't done anything super cool yet, or really gotten into the details here. All right, so these are probably just handing off to some of these fun functions behind the scenes. Anything that's interesting in main to play with? Because the functions are where the fun stuff's going to start. Okay, we've got init signal. That's probably tracking if it's running. He's getting the process ID and he's throwing in a packet loop. So packet loop is probably probably where the fun stuff really gets started in here. So let's take a look at packet loop. This is probably the actual listener function. And I could have looked for packet loop this way too, right? I'm just gonna, because I like seeing all these other functions here. Okay, so what do we got here in packet loop? A lot of variables in here. A lot of variables. That enough to tell me that this is probably where we're doing our uh, uh, all these little guys here. These are probably uh, the raw packet, right? Okay, so let me explain what I think is probably going to happen in here. So when eBPF is running on a system, or this service is running on a system, I can the kernel is going to say, here is a packet. I can send it a packet. The packet itself can be the command, right? And I don't mean like when you decode it, it says cat etsy password. I mean like literally, if the packet is just this random garbage, or even something legit, do something with it, right? Like I can tell BPF to do something just by the shape of the packet, the size, the length, the time to live value, the flags that are set on it, and I will bet you that's what they're doing here. Now let me go paint a picture on where this technique first that I first saw it, that I think was probably one of the first major uses of it. It was uh, in the late 90s. There was a Windows remote management platform, and I can't remember what it was called, a legit one, but I think it was called. They ended up calling it, the malware is called Backdoor, I think. Um, my brother ended up getting a patent on the way that this is discovered when we worked at Cisco. But long story short, what would happen is that there would be a listener, a UDP listener, and the UDP listener would only respond if the oh no, I don't remember what it was called. It was called back orifice. Back orifice. And the play on words there was the malware, or the remote admin software for Windows was called back office. This particular malware would encrypt the packets, and so in a predictable way, right? The flaw in the malware was that the crypto was bad, and so Mike was able to come up with a way to brute force it. But basically, this malware would only respond if the packet was encrypted in a specific way, right? It would the operating system wouldn't reveal that there was a service there, and effectively it was a way of hiding it. Second thing is, it was all UDP based, so you could just blast this stuff all over the internet like in massive volumes, and have this huge control over a massive botnet. And as I recall, back then, this was like 50,000 nodes. And if you put that in perspective, 50,000 nodes in like 1998, I mean, nowadays that's not as big of a deal, but back then, a lot of people were still on dial-up, right? And they were able to do it. Well, the other good news is because it was UDP based, is typically with UDP based services, you can brute force them very fast, because you can just pre-generate the packets and then just throw them at the system, right? And it'll process them, because you don't have to go through the same level of networking overhead for a UDP based piece of malware as you do for a TCP based piece of malware. And hopefully my screen wasn't dropping out there, but fortunately, I'm not doing anything on the screen yet. I'm just kind of doing the backstory on the way that this can work in that space. Now, the downside with UDP malware, especially in this day and age, is it's super unreliable, right? There's just tons, and there's so many things that will go wrong with UDP traffic in general, and filters are very good, so you don't necessarily have to have the same level of you don't have really the same level of reliability on it. So anyway, let's kind of break through what packet loop does here. Again, I think these are probably packets. It's the fun thing about looking at malware like live like this, cold. It's very hard to, if you look at the way Hollywood portrays this kind of work, you can come up with a miracle right away. But in reality, a lot of this is, it's a lot of very painstaking reassembling stuff. I joke that it's about as exciting as watching somebody do a book report. But let's take a look at this. Okay, so fortunately, packet loop told us right away that it's for a packet. It's processing packets. But when we're looking at malware, we want to look for things like this function, receive from. Now, a bad guy I have seen more than often than not, they will obfuscate all their functions by creating a different function and wrapping it. Receive from is not that. That is a native C function. And it tells me right away that this particular thing is there to receive network traffic, right? Right off the wire. Well, in this case, it's not off the wire, off the kernel, like really raw off the wire. So once we get it, he's gonna go ahead and look for this variable less than this value, this particular hex value. And then he's associating it with this. So that's telling, I mean, I can tell you right away, this is exactly what I thought it was. This is probably the authentication mechanism for the malware up in here. And then after that, whatever is left in the packet is what we're telling it to do, which is fork. Wow, what a mean process. Doesn't even thread. So fork is a way of throwing a process off into the background, but I don't see anything in here that's tracking those things being used. So they're probably using some basic raw level stuff. Nobody likes to write threading code. I appreciate that, guys. And we're going to go through the variables. So if variable var5 is 0, it's going to change to the root directory. It's going to set the SID, which is probably root. And now we are purely operating at this point. I can tell we're purely operating in userland like a shell, right? This is maybe not an interactive shell at this point, but they've gone into base userland right here. Love it. Look at this. Didn't obscure this at all. So I can tell right there if this variable length is less than 3, they're actually passing commands to it, right? They're actually saying go run this command. It's very generic. Good on you. And this one here, I'd have to dig deeper, but I'll bet you this one, at this point here, we're talking about going into an interactive shell. All right, let's take a look at some of the other functions in here.
We do have somebody asking if they can ask a question.
Oh, sure. I'm sorry. Yeah. We should always do that. Yeah, shoot. Go ahead. MC it. Charity.
Okay. Yeah, it's just you don't take breath very often, so I thought.
No, you should interrupt me. Yeah.
I told him he could. It was KF Cliff 123. But I don't actually see him in here anymore.
They might have changed their name.
Oh.
For reference, what is the question?
He didn't. He just asked if he could ask a question. I said,
oh,
yes.
okay. Yeah.
So I thought he might. Well, if he posts it again, I'll cut in again.
Yeah, for reference, everybody. Yeah, I see where it says, hey, can I ask a question? Definitely ask questions in here. I'm watching the Atomic Corp support Slack on this. I'll briefly ping over. I did just look at the MITRE attack Slack here. I know I see a bunch of people from
it could be from MITRE as well, and I don't have access to that.
Hi, Kat.
Hi, Kat.
But that's like 2 monitors away from the one I'm looking at. So for reference, if Charity, you can ping us in this chat or ping us in the Atomic Corp support chat. I've got those up. I'm looking at those. And I had gotten some from one of the Rocky from some of the Rocky people too, and they were correcting me on some of the ways that the um, BPF works. I think I covered that, which is that it does not always have to run privileged. There are ways you can run it unprivileged, and I don't know enough about that specific malware, so we might need to revisit it. But my guess would be that if it's running unprivileged, you would have had to have instantiated some eBPF option in the kernel, right? So like it would have already had to my point here is it would have had to existed before you did that, right? Like, okay, like somebody maybe set up an application using eBPF in Linux and their permissions on it were bad or their application was exploitable, and then you managed to inject over that. Of course, yeah, that's an option. But for the folks who asked me that question in there, let's, we can revisit that. I'd love to see it. I have not worked with that a lot myself, so again, I'm kind of going into this cold with some of the some of the capabilities here. I mean, I've certainly, I know my way around. I've seen things close to this, but this is my first time looking here. Let me throw in another observation in on this. This is so much easier to write than I thought it would be. When I'd seen malware that did this kind of level packet manipulation in the past, it's far more complicated. Like, I mean, way more complicated. It's leveraging libraries like libpcap and things like that to from pure user land side, put the network interface into promiscuous mode and then start talking to it. I think one of the powers here of the eBPF model is that it is inline, and that we can get between the kernel and user land reliably and lie reliably, right? Versus the pure capture based model, which may not be as reliable. We might be seeing, you might have two different, you could potentially have two different applications seeing the network at the same time, and it's kind of a race condition. The malware could be in a race condition. I don't see it like this at all. This is really, I mean, this is a tiny little function. I mean, this is extremely tiny. This is a daemon, right? So you get a wild true here. So it's basically an infinite loop, and that's it, right? I'm there. I'm done. I mean, that's nice. Like this is some real simple malware in that case, right? And then it forks the process off. Boom. Wow, that's really cool. Okay, so let's take a look at some of these other functions in here, because I'm very interested in potentially what some of the indicators are, or just some of the other capabilities that are in this guy, what else it can do. Now, I wonder if I have like a million code browser windows. Yeah, I do. Will that guy change if I click on it like that? No. Yes, no. I wonder if this even does anything. I'll have to go take a look at this later on. I mean, I didn't really see anything that talked to it. I mean, all it's doing is it's creating an endless loop. All right, let's take a look at this one. Gmon start. I guess probably this guy is going to be related to. Oh, wait, I'm still decoding the wrong thing. Not decompile start. This guy. Hey, one really cool thing you can do with Ghidra, you can modify the malware, right? You could actually take this binary and modify its functionality. That's how I would, and I've never done that with this, so I'll have to go play around with it and learn it. But like, let's say this malware had a key, like a crypto key, and we wanted to capture it. That's how I would do it. I would actually get into the malware here and I would modify the way it runs. Basically, it's the before anybody asked me that, this is exactly how you would beat license key systems in like gaming platforms and stuff like that. So, okay, let's look at this B function. What do you do? Oh, B function. You're not named. You're named both not interestingly and interestingly. So the function B looks like it is to bind to a socket. Oh, how boring. Okay, now what they did here is they probably did this. I mean, this is kind of what I expect to see when you're obfuscating malware. And nobody wants to write in C anymore, so I can see why they took some shortcuts. But yeah, they just made a function called B, and all it does is it binds to the socket. Like more complicated malware will take all of these functions like bind and whatnot, and create a new function name, like in this case B, to do it, and maybe some shortcuts. It's still going to be in there. You're still going to be able to find it. This gets spectacularly gross to work with in when you're looking at like web-based malware, right? That is going to be like that is a study in your ability to just put up with looking at a piece of code that is being gzipped 30 or 40 times before you eval it, and then all the variable names are just named garbage. We did one of those earlier, and it was we all learned Indonesian while writing it or taking it apart. Okay, B is not that interesting. Just bind to a socket. I can't imagine C read and C write are anything more than what I guess is maybe a C++ programmer looking for a shortcut to the way they would normally write something. Yeah, that's what it is. So they basically made a function to, kind of simulate some C++ stuff. Deregister clones. I'll bet you this kills off some of their forked processes. And that fork is really where we're getting into all these down here, the shells and whatnot. So your job is to go. I mean, it's nice that it creates PID files. That's kind of cool. How polite. Oh, you do nothing. Cool. I'll bet you frame dummy also does nothing. Yep, look at that. Well, no, I take that back. It's gonna run the register clone function, which is probably this. We didn't get this guy. What are you? So what happened? No, it does nothing. What typically with tools like this and IDA, if they can't figure out the function name, it'll just generate a random one like that. If you saw our one on the Golang, every function was called that until you knew how to put it back together. Get shell, I'm going to bet, gets a shell. Yeah, okay, so that's exactly what they're doing in here. This is how they're binding the shell, and then they're using these techniques here, likely to handle rendering the terminal correctly. So this is probably more interactive. I'm going to skip some of the more boring ones. Let's look at logon. I'll be honest. This is not nearly as complex as I expected it to be. But I guess it's because it's leveraging the BPF stuff. What a cool function. Okay, mon looks like this is network code. So I'm not sure why they're calling it mon, but it's allowing them to send packets on here. Maybe what they do with mon is it's probably part of how they inject the functionality in here. What to do on terminate on OpenTTY? That's probably part of the interactive shell piece. What do you look like? Yeah, there you go. This is where we're pinning it to. This is absolutely how it's handling an interactive shell. So presumably what would happen is, you send a particular pattern to packet loop or a particular request, and it effectively opens up a shell, a reverse shell to you, right? It's going to be interactive on there. Let's look at exchange before we look at W. I mean, this looks like it's just switching. It's just switching fields on it. Not sure what that's for. I mean, like some of this, I'll bet is probably. I don't know. I wonder if some of this is maybe a liberal interpretation through the decompiler, which is absolutely amazing compared to what I've used in the past. I used IDA Pro, um, and this is, I'll be honest, it's even formatted. This is wonderful to look at. Let's see. Okay, so we've got something that's W is getting. I have to go look at the context and the way this is called. I'm guessing maybe it's. Hmm, yeah, I'd have to go find where it's called to see exactly what they're using this for. Let's take a look at their shell function here. Now we're talking. So this might be a bunch of pre-configured actions. Definitely got process management right there. Yeah, this looks to me like they've got some. This will take some looking through to go and take all of these apart and see what they're doing. What's cool about these though? We're writing when we do when we revisit CLAM and the binary signatures. This is where I start getting into looking at this stuff right here to create binary signatures for the malware scanners. Right, this is what it looks like in machine code, but these values are going to be right. You can see these values in here. These are going to be unique probably to the malware, and it might do something. I don't know. Once we take it apart, we'll see what they are. But that's the kind of stuff I look for writing signatures for the malware. All right. What's setup time do? Um, no, I mean, I'm guessing this is a time function for something. I mean, it's got pretty tight. It's pretty tight. Maybe these could be related to packets in some way. As I mentioned, there are ways to, when you're creating covert channels, it doesn't necessarily have to be some kind of super interactive request. The shape of the packet itself, and there's a lot of fields that can be abused in a packet. One of them, for example, is in an ICMP packet ping. The payload field is not used for anything really. Now, depending on the operating system, Windows, for example, will put a random string, or not a random string, but a string into the packet field. But depending on the nature of the service you're using, the packet itself for the service could be the shape of the packet, the length, the TTL, those things can be used by something like this to talk to it. Now, I'd love to see if anybody's married that approach with BPF, because then when we're looking in here for commands, like this is definitely a bunch of actions that they're sending. Um, it would be it would be a lot easier to hide, right? If I sent an ICMP packet that was 133 bytes, right, or the payload field was 133 bytes, that the fact that it's 133 bytes is the command. There's nothing in it. It's blank. There's nothing in the packet. So from you, if you were looking purely from the wire perspective at that, you would just see an ICMP packet, and you might miss the fact that it was the length, right? Or I could change the TTL. Now the TTL in a packet that means the time to live value, and or the packet sequence number. All of these methods have been used for other tools, either to create to enumerate a service, right? You can definitely use those fields. But also as a covert channel itself. Going back to ping, so the payload field in a ping packet can be used and has been used for many years now to create VPNs, right? So you can create a VPN just by pinging something. I'd love to see if that's happened with this guy yet. All right, let's get into the file system because we've only got about 10 minutes left. And I will bet you already that the this guy is identifiable by clam, but we'll see. Maybe I'll update my clam DB at the same time. For the sake of, I think for when we were playing around with writing clam sigs, I wasn't running a clam D as a service. I'm running it as a pure userland action, which means that this guy has to go and load. Ah, terrific. Awesome. Okay, so the good news is clam, and the bad news is clam AV does not have a signature for this malware, which means we can use this in our next clam session to write a malware sig for it, which is awesome. So the downside is you are leveraging clam AV to find this Linux malware. It's not going to find it, right? Let's go grab some of the other ones to see if that's true across all of them. Now, it could be that the reason why it's like that it's not found is that, and we'd have to ask Tim if he has any backstory on this. Yeah, awesome. This one's source code. Boy, I wish I would have picked that one first. That would have taken all the fun out of it. And you know what? When I was looking around, and look at this, I think this is the source code one. When I was looking around for initially looking this up a while ago, I found on GitHub bfdoor.c, right? And I'll have to go see if that is the same thing there. But it was I was like, oh yeah, sure, let's take a look at that. I was like, it can't be that easy, right? So I already dumped it in there. But we just looked at that and saw the same function calls. All right. Smaller, much smaller. Look how tight that is. 10K smaller. Now, it could be because this guy's, they stripped the symbols off of it. In fact, let's take a look at that. Let's see if they did do that. Aha, that one's got a signature. Cool. Okay, so we've got two different versions potentially. We don't know for sure of this malware. Not strings. I don't do strings on there yet. Let's look at the magic header on this guy. I'll bet you it's static. Ah, but not stripped. And dynamically linked. That is not, I do not normally expect to see malware that is not dynamically linked, or that is dynamically linked. That's maybe that's an artifact of doing things with BPF. I don't know. Let's take a look at this one says here. No, not you, decompiler. I'm not going to take this guy apart. I just want to take a look at a really quick part of this. Given the size difference, I mean, it's definitely a shorter number of functions there. Very different. Well, not very, very different, but different. Right. I see these ICMP. Aha. Remember what I was talking about with ping, ICMP? There we go. I'll bet you this. They are sending commands in the payload field of a ping packet. Man, I wish I would have looked at that one first. Yep, indeed it is. That is absolutely leveraging ICMP ping as the control channel. Okay, we are down to just like about 5 minutes here. Anybody has any questions, please let me know in the chat here or looking at the support. That would be fun. That's all about mod security. We can always do that. We definitely will be talking about mod security soon. Yeah, we will absolutely be talking about mod security in in short order. In fact, all right, I think maybe the way we might do this is mod security and libmod security for Nginx, mod securities for IIS and Apache can be, we can implement malware scanning in both of them. And well, at the very least in libmod security, or sorry, mod security. I double check on libmod security, but mod security, we definitely can do malware scanning. We can leverage either CLAM or we can leverage SSD. So maybe what we'll do in our next session is we can come up with signatures for the version of BPF door, or BPF door that is not identified by CLAM. We'll write a sig for this guy. Maybe we'll do a binary one. We'll keep it less on the taking it apart of the malware unless there's a lot of interest in that, and more into the signature stuff. Because what we did in CLAM last time was very basic hash-based stuff. We can get into either Yara-based signatures, which I think is a really good topic to blend together here, or the binary signatures. And then instead of doing it all through the command line here with CLAM scan, we'll actually put it on a web application, and then we will test pushing this malware up through a web application, and then watching what we can do to intercept in line, right? It's kind of cool there. We can do it in line, and maybe that might be too much to get into the IPS mode for CLAM, but we can definitely do an inline verification with mod security on this specific malware. All right, well, this is kind of wrapping up our time for today. I hope you enjoyed it. If you're interested in presenting yourself, or being on the presenting panel here with us, please let us know. This is open source security. It's open to other researchers or other techniques. Our theme is really to focus this on not so much malware. I mean, malware is what we're doing now, but really open source security in general. So malware reverse engineering, countermeasures to malware, detecting it, preventing it. I also work on a project called Greenbone, which is a open source network vulnerability scanner. All of those tools are in scope, and what I really want to kind of theme this is how we can blend open source security tools together, right? Ghidra is what we're using to take apart the malware. That's open source, I think, certainly free. CLAM to detect it, that's one tool. SSDeep is another tool. Yara is another tool. And then looking at the malware side, but then blending it up into the application layer with something like mod security, or whatever you're interested in. And we definitely have some people asking about mod security. So I think we're due for a mod security discussion on our next one. So once again, everybody, thanks for joining. If you're not on our Slack channel, please get on that so we can talk. By all means, reach out to our support people. My name is Scott Shin. I am with Atomic Corp and the Rocky Linux project. Joining me today was also Charity on the MC side, and the other folks from here from Atomic Corp. Thanks for joining. Bye.
Thank you. Bye, guys.